Hey guys, welcome back to the Rust Intermediate tutorial, and today we're going to be talking about generics. So I'm going to slide this thing down here. Now, a generic is a pretty powerful tool, but you got to use it carefully, and we'll talk about why. But first, let's type out a few generics that we've already seen. So the first one's going to be option, of course. And this is what an option looks like in raw form. I've already done this before. And this is what a result looks like in raw form. And you can see that they're both using these weird, like, capital letter, I guess, identifiers. So what's going on there? So they've got this, like, T and TE, and all that really means is you can pass any kind of data type in here. So if you use an option and you specify it to be a string, you can do something like this. And it's totally okay. If you want it to be an I-32, it could be an I-32. But instead of like defining all different copies of the same thing, you just put this T in there, and then you can reuse it with different stuff. Now, the key is when you use generics and you're using, basically a wildcard for your data type, you have to be careful that the methods and the functions that you run on that data type inside your function, like if this was more than just a basic enum, that they have to be compatible, and we'll see that going forward. But basically what these allow you to do, and I'm just going to copy in some examples that we've already seen here. Like, for example, here's an option being used for a particular function there. And you can see that this time we're using a string. So we're able to use some here and put in a string, and then none, you don't need any kind of data type. Now, again, if we change this to an I-32, you could see the same process as before. And I'll also put an example in for result. And this is just going to be the error handling example from the last video, actually. And you can see here, OK is allowing us to just continue with the command. And in this situation, we don't actually have anything going into OK that's like a data type. It's just a process. But our error is still of type E, which is still of type error, right? Like, just because it's a capital E doesn't necessarily mean anything. But you could see that these are really powerful tools. And you don't have to just use them with enums. Now, you could define your own enums, and you can build this same functionality. Like, you can have some kind of custom enum that maybe does something like this. And you could do like... I don't know, we'll just do like T for an example, and we'll just say example of T or sample of T, whatever. But you can see the idea is there that you can create your own, and you can have your own, values in there for data types. You can also do something like this, and you can have two different types of data types in your enum. And that's what's going on up here in like the result one. So pretty interesting stuff. And this isn't limited to just enums, like I said. We can also do this with structs. So here's an example of a struct that is going to use one particular data type. Let's just go with height and width. And you can see that obviously no matter what kind of number, or even if we did a string, like we would represent the height and width with the same data type. And just like before, if we wanted to do multiple data types, we just got to come up with different like uppercase representations for each data type that we want to pass in. And in generics, it's just these uppercase letters. And so we'll do height T, width U, and length V. Nice. And that's exactly how you use those structs with generic data types. And here's just an example of that in practice, like initializing these structs. So if we just let rect1 equal rectangle, and we say height is going to be 1, and width is going to be 2, and then we copy that, and we change these to, I don't know, like just make them floats instead. You can see that that's perfectly fine. We can use ints or floats. It doesn't matter because we've got generics. And the same thing goes with the cube. We just go ahead and create a new cube. we could say height is 1, width is 2, length is 3, and then we can copy that, and we can change these to like 3.75. We can leave this one as an int if we want, and we can make this like 1.54. See? All totally valid. So let's recap here for a second. We obviously covered structs and enums, and I went kind of fast because the concept is quite straightforward, right? Like these are just placeholders, and inside anywhere you see one of these capital letters, you can pass different data types. And that doesn't really get complicated until you start to use functions or methods, and you start to have issues with like type compatibility with the different operations you're trying to do. So let's take a look at functions. And when you try to initialize a function with a generic, first of all, it looks like this. You have to type the function name, and then you have to pass in the generic in the function header like this. And then you pass in your object, and you can just have it be of type T. And you can also do like a return value, so like if we wanted to return T as well. But here's where you're going to start to have some issues. Like what if we wanted to do, instead of generic function, let's just do like sum of numbers, right? Now already just calling it sum of numbers, that kind of takes non-numbers off the table. So kind of something to note right there. But let's just say we wanted to return, let's just say we wanted to do like two numbers, num1 and num2, both of the same type, and we want to just return T. So we're going to return num1 times num2. Now, right away we get an error. Now, all our types check out, our return type checks out, everything's cool, but what's this say? Cannot multiply T by T. So why not? Well, Rust doesn't know what you're going to pass in here. We haven't written any logic yet, like the compiler doesn't really know. And even if we go ahead and scroll down to main and we just say like sum of numbers and we pass in a 1 and a 2, it still doesn't work, right? Like it's fine down in main, but we still have this problem up here. And that's because Rust is warning you like, hey, this is a generic function, but this operation that you've provided is strictly limited to numbers. So floats, ints, even unsized integers or unsigned integers. So you can't just implicitly apply numerical operations onto a generic because it could be a string, it could be an option, it could be an enum, it could be a struct, it could be anything. So this is where you have to be really, really careful with generics. Let's talk about how we can actually deal with this kind of thing. So I'll bring this up and let's just try to print the result of what we're doing here. And now let's see what Rust says when we try to do a cargo run. So we know that this was coming, right? And it says consider restricting type parameter. And then it gives us this suggestion here. So we already talked about why we can't do this, but what is this? Well, this is actually what's called a trait. And basically what's happening here, because we're going to talk about traits in the next video, I'm going to quickly just summarize. This right here is you declaring that this generic type T has to implement this trait. So in a nutshell, since this is the multiplier trait, we're basically saying that I know we're defining our return type to be a multiplication operation. So anything that gets passed in as a generic is going to have the multiplication trait. And that limits it to number types that are only going to be able to conduct this operation. So if we just go ahead and put this in our function header, just like they told us to, you can see that all of our errors go away. And if we run this, we'll actually get our product. See, 2. And now that's exactly how you can restrict your types but still use generics. And that's the recommended way to do it in Rust. And next video, we're going to talk about traits, and this will be a lot more clear. But just for reference, I'm also going to provide a function example that is basically a function that you're not going to need to restrict the data type. But it's tricky because there's not a whole lot of use cases for this because of what we just saw. So I'll give you guys a simple one. Look up data type. And so we're going to pass in a generic, like we said. We're going to have object of t, and it's actually going to return nothing. And we're just going to print what the data type is. So I'll just do something like this. And we're going to use std, any, type name. And this is a little bit of like a hack, I guess, because this is one of like the only use cases I can think of where you can have an unbound generic, like completely irrespective of any kind of trait. If you guys can think of other use cases, try them out. But the trick is here, like anything you pass into this, whatever you do to it has to be applicable to pretty much any data type that you can possibly pass in. And so, you know, just printing out what the data type is, that's a pretty straightforward operation. So if we just do like lookup data type and I just pass in like a 1, or if I do 1.96 or 95, whatever, and then maybe I also do a string slice, you can see that when we run it, we're going to obviously get back the data types. So that's an example of how you can use a purely generic function. But this is going to be your best bet here. You're going to want to use traits, and you're going to want to have some kind of restriction in order for you to be able to actually do like operations and stuff within your generic functions. And again, these kind of function rules, they go for methods of structs, methods of enums, associated functions for the two of those, any kind of function. This is the case. So I hope that made sense. I know it's a lot to unpack, but I think once you guys see traits in the next video, this will all come full circle and we'll be good to go to start building some really cool object-oriented stuff in Rust.